Hi, so myself Darshan Shah. I have currently I am located in Dallas. I have approximately 5+ years of work experience working as a big data engineer, and in this 5+ years of work experience, I have hands-on experience on many technologies using Hadoop components, Spark, and other like data ingestion tools, data processing tools, data visualization tools, and all. Currently, I have been working for Staples as a data engineer over there, and my job is to load the sales data and give it to data visualization team. So, besides Hive and Scoop, I have used many other Hadoop components. Those components are like Flume. So, Flume, Apache Flume, I have used for log processing the data to get the different server logs and analyze it in Hadoop using Hive regex Saturday. And I have used MapReduce as a Java program for many things, like for writing code, for a semi-structured data, and also for unstructured data that we used to get from MongoDB. Then this is the data processing was used like in my application. I used a combiner and a partitioner in MapReduce to improve, basically, you can say many things, like one of them was performance of the map reduce job. Also, during these two things I have also, apart from these two things, I have a good work experience on the field of Spark. I have used PySpark, Spark SQL for data processing, and I have used that because it used to work much faster. Apart from that, like MapReduce, I have also, like, I used MapReduce basically for distributed cache, to basically read a small data set, and I would fit that into the memory, and then I would get the output from the mapper. MapReduce can basically handle structured, semi-structured, and unstructured data, since we had all these data coming at our staples project. So it really depended on for which data what to use, the structured and semi-structured data which we had, we used to get from our databases like SQL Server, and unstructured data we used to get from MongoDB, and I use these. So I have done this optimization in Hive. Then you can say that this optimization was basically, once we got the data from Scoop, and then we imported into HDFS and then used Hive as a data processing tool. Uh, I have used, for optimization, I have used partitioning and bucketing, and we use this for basically creating a partition. It might be static or dynamic. We have used both. It was based on the different column values that we had. Uh, we also we also used, like as I said, dynamically, dynamic partition, where we would load the data into the partitioned table, and load the data into partition table and create the columns, rather than me explicitly just naming the column names. I have used internal and external tables both over here. Then I used bucketing further. Uh, then the process, for example, I created buckets in partition to generate the output according to the business requirement asked. It would really depend on the query, or what the client is looking for. Then I have also used query tuning in Hive by using map side join and bucket map join, also skew join. Uh, you can say that I have also used cost based optimization in Hive query. These are the different optimization processes I was working with the Hive. And in Hive, I used to tune the performance and make it as optimized as possible. We are using inner join for bringing the data from two table based on a common key from both the table. You can say that outer join is basically bringing the data from left side to right side table, uh, and all the matching rows in the left outer, and all the matching rows in the left outer, and basically bringing to matching the rows in the right from the right table. This is the main difference between the inner join and outer join. And this in this there's a left outer, right outer join. So the left outer and the right outer join is basically, as I said, left side to right side, matching all the rows in the left outer, and bringing to matching the rows from the right outer table in the right outer join. You can say we have full outer join as well, where we get all the data from all the tables, irrespective of the matching values. It's like, for example, there might be repetition, there might be like the data won't be matching, but we use the fuller outer join basically pull out all the data. There were many challenges in which, like in terms of a block on a project which I have worked on here at Staples. I can relate to some of them with the Staples which I had. So in one of the project at Staples, I worked on a migration project where I had to migrate the data, migrate the data on premises to cloud basically. So the main challenge over in this migration project, which I had to face, was the security issue and the data format support on the issue on the cloud. So for that, basically, to resolve those two problems, we I used for our own security mechanism, encryption one technique. I used that for basically securing the data, and I applied and basically my team applied a different data format support on which like a data format applied which was supported on the cloud. So while moving the data on while moving the data on cloud, we have created a data lake on cloud, and this basically resolved this problem. And also, as we created this data lake, it had many text, many support formats in it, and we uploaded that only. That was one of the again, that was the challenge. I basically from then after creating that data lake, we used to read the data, and then we used to so for this, what we do is, firstly, we split the line, and while splitting the line, we do that using this it by comma, and by then what we do is we create the string of the array, and convert them this array into integer. After this, convert them to the integer array. Then once we convert them to the integer array, for displaying them separate array list, and once we convert them into the integer array list, and then what we do is we call Java 8 stream function, and we then call the distinct function from Java 8 as well, and also call collectors to list. Basically, we add two lists to it and then get the values in the list. Once we do this, what we do is we basically use a string builder, and after build after for we use a string builder basically for concatenation of command of each number in the list, basically of each number in the list, and string builder, and basically, and then use the last command I did is to remove my substring. I had to remove using this substring function, and basically print the final string. Um, that's how I basically tackled this problem. In the last code, where we had to push and pop and basically take the alternate values like from the back. So for that, what we had to do is, firstly I had to create a reverse alternate function. For this reverse alternate function, like this reverse alternate function was taking the input as a string array, and inside this function, basically we had created the stack of integers type, and basically we used to get all the values, and these values were basically were from string array, and then we inserted those values which were from string array into the stack using push operation. After that, the next step was basically we have we had to run the loop, and we run this loop till the length of length of the string. We did this using logical end. We did this using logical end operator basically, and uh, so now in the next step, uh, we create we so we did this with one to I value, and this was basically starting from zero to length, and zero to length, and then append this uh, and then basically I had to append this with stack dot stack dot pop operation, stack dot pop operation with space, else only stack dot pop operation, like stack